Hello, my name is Leo Salavo. Today we are going to talk about Internet of Things, and maybe we should talk about Internet of Humans instead. Or is this the same thing, or is there a difference? So that's what we're going to try to figure out today. Okay, so I am from the University of Latvia. I'm a professor there. I have been there for a few years, but before that, I studied at the University of Pittsburgh, and I have done a couple of other things. So just a couple words about myself. I love skiing. I love skiing so much so that when I was going for my PhD at the University of Pittsburgh, I also joined the National Ski Patrol in the United States of America. So that gave me plenty of time to spend on skis, but also plenty of time to spend helping people, giving medical care to them, the people who got into accidents or had some sort of problems on the slopes on the mountain, so to say. So I never thought I'm gonna go into the medicine or into the healthcare when I was a kid, or even in high school, or even at the university going for my bachelor's degree. But somehow it happened that I started to go more and more towards healthcare, right? So in the meantime, I do like nature a lot. So on the bottom right half, you can see the edge of a volcano, or used to be a volcano. On the right bottom side, what we see, it's Kilimanjaro. So this is the highest mountain in Africa. So I happened to climb up to the edge of it. And now, at this point, I'm at the point where I still have to eat the tail of the elephant while the whole elephant is eaten. I still have to hike a little more, but that was the hardest experience at the time. So it was one of the hardest experiences I've had because there's, low oxygen saturation at that level. And it's not the case that the oxygen is not enough there. It's more of the case that the pressure in the air is lower at higher altitudes. And therefore, we cannot get as much oxygen in our lungs and therefore in our blood. So one thing that I was thinking at the time was, wouldn't it be great if I had a sensor on my finger or somewhere that would measure my blood oxygen saturation? The kind of device is called pulse oximeter. I was building my own pulse oximeters at the time and connecting them to networks of sensors and trying to build systems that are helping people, that are helping elderly people in their homes. We had projects like that. Another project on the bottom left half is island in the Atlantic Ocean. So it's not quite a Robinson Crusoe kind of experience, because we just went there, we left some sensors there, and then we came back from there using a high-speed boat, which was fun in itself. But it was an experience of, okay, suppose you are in an environment where you don't have electricity, you don't have, any kind of support or infrastructure. Nevertheless, you want to measure something, you want to see what's going on in that environment. So the big question there was shrubs. They're not quite trees, they are kind of like bushes with lots of branches. And what environmental scientists were telling us, they are taking over the island. And maybe they will take over the world in the long run, right? So there you go. Here's a conspiracy theory for you. The question is why. So they didn't quite know, why is this happening? Why is the grass not growing under the shrub thicket? Is this the lack of the light, or is this, biochemistry of the soil? Because seems like there is light, there is, the chemistry of the soil is not that much different. But what is going on? So what we created kind of like digital camera, except the lens of the camera, or the picture that it's taken, it was spanning, several meters on the ground. So basically it was looking at the light environment that is there for the grass to grow or not to grow. Right? So we had a bunch of sensors there on the ground. We had a system. The sensors were talking to each other. They were sending the data to a relay station that was sending the data across the big span of water, about 18 kilometers or so, to the mainland. So that island, it wasn't too far away, right? Not in the middle of the ocean necessarily. But nevertheless, it was a very remote place. So that's kind of how I started working on the sensors and sensor networks that, became this thing that we call the Internet of Things today. All right. So that's me. That's my experience working on different things related to sensors. related to computing. I do come from a degree of in computer science, so that's my passion. But I often have my feet in both software and hardware, and moreover, not just hardware, but also in sensors. And more, I am collaborating with different fields in doing interdisciplinary research or applications that hopefully will help the world and help the humanity, the society, and so on. All right. So that's what I'm gonna tell you about.
I just wonder why people even decide to climb such things as Kilimanjaro. I mean, it's dangerous.
It is dangerous, but don't we love a challenge? Well, sometimes we do. Sometimes, if we set the goals that are just down there, then that's what we're gonna stay. We're gonna stay down there. We're gonna stay in our little home or wherever we are, forest, fields, city, village. But sometimes some of us, we want to climb higher. We want to see further, because the higher you climb, the more you see, and you can take in the whole picture. And that's also I have in mind when I'm talking about a macroscope, which is going to be the next thing. Macroscope. So when you climb a mountain, you can see far. You can see what's going on down below. You can get a different perspective. That's one reason why I like to do that, to have a different perspective. So what I'd like to call this a macroscope, right? And actually, this is not my term. This term was coined by, I believe, David Culler and his research group at University of Berkeley in 2005. So that's about 16 years ago. This was sort of the rise of the wireless sensor networks. This was before the Internet of Things as a term was coined yet. But what they did, they had a bunch of little sensor nodes, such as up there in the top right corner of the slide, and they placed them on a redwood tree, on a tree that's about 70 meters tall, to observe what is the environment there, to see what is the temperature there, what is the humidity, what's the light environment perhaps as well. And what they discovered, that actually the micro environment, where that biology all lives there, is quite different depending on the height that the higher you climb, the more different it becomes, right? So on one hand, that's something that you could have guessed, but on the other hand, now you have a tool, you have this macroscope that enables you to look at the big picture and perhaps draw some conclusions and make a decision, make an action that's based on the data rather than just on guesses or some distant observations. Right? So macroscope, as opposed to the microscope, which was discovered more than 400 years ago, I believe, right? That allowed us to look into very details in very small things and brought a lot of good things to us, right? So the macroscope has, if you will, has been discovered not too long ago, and we are on the onset of using macroscope more and more. Internet of Things is sort of part of that macroscope concept, the way I see it. All right. So these little sensors, let's start from those sensors, and as we move through the presentation, we're gonna go to the big systems and even how they affect business or society eventually. All right. So these sensors, if we look at those sensors, in fact, sensor is just a device that converts something that happens in the world, some physical value, let's say it's a temperature or maybe it's the light level. It converts that to a, first analog form in electronics, and then we convert it into digital form so that we can have it quantified as numbers, and then we can process these numbers. We can, add them up together. We can filter out some noise, perhaps. We can try to make sense out of them, right? And if we do that, if we collect this data again and again and again, once a second, once an hour, maybe once a millisecond, depending on what you want to do or when you want to do it, then you can send this to, let's say, a database, to a data cloud, to somewhere to store that information, and also to do a post-processing on that information, right? Once you have the post-processing, then you can have decision based on real hard data, on hard evidence, right? Rather than guessing, oh, let's try this or let's try that, right? So sometimes when you go to a doctor, you say, oh, I have a headache or some other problem. And the doctor says, well, let's try this medicine. Let's see how it goes. Wouldn't it be nice so that we could have a more hard evidence saying that, okay, you need this medication, you need precisely this many milligrams, and this is the schedule how you should take, right? I hope that we're gonna move towards this more and more with the onset of digital healthcare, but that's a topic I'm gonna talk about the next time I have a presentation with you guys. All right, so the sensor nodes themselves, they're quite tiny. So I have on hand on my table, for example, this one device. See how tiny it is. But what it has in there, it has three kinds of sensors. It has accelerometer, it has a magnetometer, and it has a gyroscope. So what this allows me to do, it allows me to shake it, and it will notice how it moves. I could, for example, put it on the back of my neck, and it could tell me, if I'm sitting straight up, or should I, go and move a little bit? Am I a little bit crooked? Or, this is just one example of the sensor. It's tiny, it's light, it has a battery, so sounds good, right? Now the challenge there, though, is that you have to work in very limited resources when you work with devices like this little one, right? And in fact, there are even smaller devices, as we will see today. So it has to be very small. It has to be very light. So you can't put tons of electronics in there. You can't put big processor with a big fan on top of it. You cannot, put a huge car battery next to it. In some applications you could, but if I want to put this, let's say, in my coat or in my shoes or somewhere else, there's just no space for that. It has to be unobtrusive. It has to be light. It does not have to change my life. It has to observe my life, right? My actions, my dynamics, and so on, if I want to use it. So it has small battery. It has small memory. It has small processor. It does not have a lot of power, so it cannot broadcast a lot of, data far away. And there are a lot of those guys. Remember in this tree, so they had something on the order of maybe 70 nodes, 30 to 70 nodes. I don't quite remember, but that would be a typical number. Just see of how many dots there are. Each dot is one sensor node. They have to talk to each other, and they also have to deliver that information to the cloud, if you will, right? So all that takes energy, and that's why it's a very challenging field. From the data processing, from the computer science point of view, and also from the electrical engineering point of view. That's why I love it. I love the challenge, as you heard earlier. So it doesn't have to always be a big mountain. It could also be a very small and tiny device, and see what can I do with this device? How can I do more with this device? Right. So that's my passion for sensors and sensor networks. So this is the theoretical, technical side of it. How do they look like in real life? So here are a couple of devices that I have made some time ago. So there was a project at Harvard University. I collaborated with them on Code Blue project. And this was one of the projects where you would have wireless sensors that you could use in an ambulance, for example, emergency ambulance, or on patients, and patients, they don't have to be on the bed all the time. They can walk around, or maybe sometimes you have a huge disaster, God forbid. You have a lot of patients, you have very few medical personnel. However, you have these sensors, you can attach them to the patients, and they can monitor the health, the pulse, heart rate, the oxygen saturation, and things like that for that patient, right? And you could even have a call button or some other sort of user interface attached to these devices. So that was one project, one of the first projects that I participated. So what did I learn from that? I learned that it's not enough to have a cool device that does its thing, but device actually has to comply with whoever is using it. So device, if you are using it in a medical context, it has to be nice and clean, and it has to be, you should be able to disinfect it. It has to be prone to physical damage, if the patient is pulling at it, or if it hits something. So it's not just about the, electronics or algorithms or programs or applications. There's a lot more. So you have to talk to doctors or to whoever is responsible for that environment or for that research or for that application. And you have to speak their language. You have to learn their language. And once you agree on certain things, then you can, achieve something. So I remember we had a pilot in one of the hospitals in Washington, D.C., I believe. No, sorry, that was in Boston. Not that it matters, but the story was as follows. We placed those sensors, and they were sending data. And, being computer scientists as we are, we saw that some of the data was dropping out from the heart rate. It was not just the heart rate, it was the ECG, the cardiogram, right? So we say, so there's a dot, and this one is missing. So we thought, we can just, interpolate that one. See something in between. That's probably what it was, right? So we would have an algorithm that would paint the missing dots, add them to the, patient data. So once the nurse saw that, she saw, this is not right. This could not happen with a human heart. So you're out. There was not much discussion. It was, it's critical to the health of the person. You cannot, play just the way you feel, the way you want to do. You have to agree with the particular environment, with the particular field. You have to play by their rules. So I guess that's one lesson we learned. But nevertheless, we had many more pilots in different environments, and it was pretty cool. We actually made a startup out of it. So here's another mote. So this is about how small can we have this. What's a mote? A mote is a sensor node. And this story is about how small can a sensor node become. If you see, this is 1 cent. So this 1 cent is from a US currency. But if you look at the EU currency or many other currencies, the smallest denomination of the smallest coin is usually, small enough for everyone. So this is how small that mote is. It's actually way smaller than the smallest coin. So great technology brings us these things. On one hand, okay, we engineers, we can, attack the problem. We can make things really small. We can figure out how to glue chips on top of each other and interconnect them. We can figure out how to add, fancy battery and how to use light to communicate with the sensor node. So all that is great. But what is the big question? What do you think the big question is? Is the big question how to build these things? There are a lot of questions like that. But the big question, I think, is what is it useful for? What is the application? What is the motivation behind building things like that? I mean, it's cool to build toys, but if they are just toys, then sometimes it's not enough, right? So, that's the lesson learned from this slide. Figure out what the application is, what the requirements for the application is, and then build the thing that is tailored to this application. All right? Of course, there are a lot of applications that could really use a small sensor node like that, right? But keep in mind, that's an important question to ask. Now, this is another story. This used to be my car a few years ago, and we participated in a project that's called Grand Cooperative Driving Challenge. In fact, it was a competition. So it was an international competition where anyone can subscribe. 11 countries did participate, 11 teams, and one of the teams was from Latvia. So I was leading the team. So I figured out we could make a smart car. We could make a car that's sort of self-driving or almost self-driving. In fact, the story here is not about self-driving. The story here is about cooperative driving, where cars cooperate together. with more or less participation from the drivers, but the cars know who's in front, how far that car is in front, who is behind, what's the intention of the car in front. As we move in a platoon, car behind car behind car, what if there's another car that wants to merge in there, so that our cars can sort of move apart so that the third car can move between us. And this way you can make the driving safer and also more efficient. So there was a competition, and the competition was about who's gonna follow the rules the best. And the funny thing was that the first place was not to the car that was, the best performing. They got the second place, because at some point they were, trying to maintain the distance so well, and they did it so well. So the distance was about, you have to maintain 10 meters while driving at 90 kilometers an hour. So that was one of the tasks, for example, while the cars are communicating with each other electronically, right? So the car is controlling the gas and brakes and so on. So their system was performing really well. They were from one of the teams from Sweden. And however, they did increase, they crossed the speed limit. So even if here's the lesson learned. So even you have a technology that performs very well, performance is very great. It can save you a lot of energy. It can do many things. You still have to follow the rules. You still have to follow the laws. There are no excuses about that. All right. So one might ask, how did we do? Well, we got a 9th place. It's not the first, not the third, but we did participate. Latvia is not a big country. It was quite an honor for us to get there. So down at the bottom, the picture on the right, that's our team working hard for about 7 days. The competition took place in Netherlands. So we're sitting there and almost day and night working hard and building the car, writing the software, converting the systems, making a sensor out of a tin can, the cola can, and some wrapping paper and things like that. So it was a lot of fun. Now, guess what? You don't have to have, a car or an expensive equipment to actually, play with sensors or make a difference even with sensors. So here you can see there are a lot of cheap electronics kits available, such as Arduinos or Raspberry Pis, and you can connect them with sensors. You don't have to even, to learn how to solder. You can just plug and play these things together. You need to learn a little bit how to write software for these things. And then you can create, for example, a home environment monitoring system, right? Which is a pretty cool device. I mean, maybe you have a device already at home that measures environments such as this one. So I have this device. It's built by a company also coming from Latvia. It's called Aranet. And it's measuring the CO2 level. Right now it's below 1000, so it's still green and I'm good. But if it's gonna climb up, I'm gonna have to open the window and to air the room out so that the air quality is better. And especially with the pandemics, with the COVID, with the viruses in the air, we need to ventilate the rooms. And this kind of sensor device, or even the kind that you see on the screen, may help you with that. And you can build it. You can build it yourselves. You can build it in schools, in clubs, maker spaces, wherever. And there's lots of information available online on internet that help you to start out with these things, that teach you small, easy projects, and it's even better if you have a community, or if you build a community that is actually working with these. So that's my story about the sensors for now. So what I'm gonna talk about more is going to be with the more focus on the Internet of Things. So let's see what we can achieve using sensors like that. So far we have learned that we can place them on a tree, on a redwood tree, and then figure out that, oh wow, so the environment is different, right? So people have measured temperature all over the Earth in different places. The average temperature on the Earth is 14 degrees Celsius. The maximum temperature is 70 degrees ever recorded. At least at that point it was. The minimum temperature is minus 98 degrees or minus 93, depending on how you measure, depending on whom you trust. These are the numbers. Where do we go from there? All right. So I'll give you another question. So look at the picture on the right? So up here. So that picture is from another picture that's pixelated. So it's just an average color for pixels in that picture. So first I thought I'm just gonna take one average from all the pixels in the picture and give you that one color, see what you can make out of it. But then I thought, oh no, that would be too harsh. I'm just gonna give you every 50 by 50 pixels are average in this picture, and that's what you get. Now, what can you tell about this? Well, in fact, there is no right answer. These are facts, but facts alone, they don't make a difference, unfortunately. You have to put them in the context. You have to figure out what to do with them. You have to, create a story out of them. So we did place sensors in all kinds of sports events in the UFC, for example, Ultimate Fighter Championship, and they went also and placed sensors in the New York Fashion Week, for example, or Berlin Fashion Show. All kinds of entertainment events or sports events. Yes, we can measure the speed as the athletes are moving and so on. We can measure the temperature in the air, but it's not enough. What we really need a story. If you want to tell somebody about it, you need to create a story. How do you create a story? Based on the hard facts. That's the important question, I believe. So let's talk about how to get from those numbers, those facts, to story. This picture on the right side, that's the original, right? On the right side. So this is the smart thermostat by Google. Formerly, the company name was Nest. On the left side, you see a device that is controlling the temperature in a room or in a building, perhaps. So basically, it's a switch. It's a switch driven by temperature. So depending on the temperature, it's going to either turn on the furnace, and that will heat up the room, or turn on the air conditioner, and that will cool down the air in the room, right? Device on the left of the screen, this one, is the simple thermostat. Device on the right is what's called a smart thermostat. So my question to you now is, what makes the smart thermostat smart? I mean, how can you make it smarter? All right, so maybe you say, or you think, let's add some sensors to the device. So let's add network connectivity so that it can use computers and compute something. And let's add some actuators, but guess what? The left side also sort of has it. It doesn't have a computer, but it has the sensor, except it's a physical one. It's like a metal that can bend when the temperature changes, and then it kind of connects or disconnects. Then it has the network. It has a wire, electrical wire that goes all the way to the furnace. And then it has the actuator that turns on the furnace or turns on the AC. All right. So in that sense, it's not that much difference from the smart thermostat. What makes a device a smart device? What makes this what's called Internet of Things? A device that's connected to the internet and that does magic. What do you think? Okay, so what I'm hearing is it helps you to make decision, or it helps you it drives you to a better action. It somehow improves your life, your environment, something like that. That makes sense to me. All right. So the question is though, how? I mean, what? It's just a thermometer. What can it do to improve your life? One thing though is that what I'm hearing from you, you seem to be in a frame of mind that this device is kind of telling us what to do, and then we do that. And this could be the case. So in some applications, it should be the case. For example, in healthcare, a sensor device or a system, it should probably tell the doctor what it has observed, and then the doctor takes action or makes a decision, because doctor has more experience and knows more about the patient perhaps than the sensor device. Now in this case, this thermometer, it can actually manipulate the temperature. It can tell the furnace, hey, heat up or slow down. Right? So what makes this device a smart device, or as a device for Internet of Things? So there are some of the features that it has. So it has an application. It has an application for the smartphone, or you can go online and you can sort of control how it works. You can set it up to be cooler at night, if you will. You can observe the history, how your temperature was changing, and so on, right? So it has a software. So anything a software can do, a piece of software can do, that's the limit of their power, right? Now, it is also kind of what you call smart, right? A person could be smart. How can a sensor be smart? So here's the example. So it has the local smartness. So as you set it up at home, for about 2 weeks, it will observe how you are using it. So the way it's built, you can actually take and you can turn it, to one degree or to the other degree, and make the temperature in the room hotter or cooler, right? And for the first week, you just do it as you please, right? And it observes it, it learns. It figures out, you usually come home around 5 p.m. You like the temperature to be hotter, warmer. Then you go to bed. You like it to be cooler. Then you wake up in the morning. Again, you want it to warm up a little bit. And then you leave for work. So there's no need for us to heat up the home. We can save a lot of energy that way, right? And consequently the money, and also we can make the whole system greener, if you will, right? By saving the energy. So it learns and it can adapt. And then after a couple of weeks, it already has set the schedule more or less towards what you usually do. And all of a sudden you find out that you don't have to go and change the temperature. The temperature is already there the way you expected it to be, right? And not only it shows on the display, it actually has turned on a little bit earlier so that the heat can actually heat up. The room or the house could heat up. And the same thing. So there are more things. For example, as you go away, as you come closer to the home, it feels that you are coming closer. How does it feel? Because it has the application on the smartphone. And if you have allowed it, it will do what's called geofencing or geolocation. So it will learn where you are. It will figure out, you're on your way home. You are about, 10 minutes or half an hour from home. I better heat up the home so that when you enter the home, it's already nice and warm rather than cold. And then you have to go and crank the heat all the way up, and then it overheats. Then you have to turn it down. So you're not so comfortable. You're wasting more energy and so on. So that's what a smart device means. All right. So it also is hopefully attractive to use. So it has an effective user interface. That's what I mean, right? So that I don't have to think a lot. I don't have to take out my keyboard and type some stuff to change that temperature. So I'm just simply go there and I turn it a little bit right to the little bit left, and that's it. As simple as that. So that's just as simple as the other device on the other side, right? This device, in terms of use, but the effectiveness, the smartest, is way higher, right? So it also may influence us. So that's one thing I think that you mentioned, that it may tell us and advise us in some ways. So it may actually influence how we act. For example, it tells us that, hey, we are in the green mode right now. That means good. That means we are saving the energy. We're spending less money we are better for environment. When it shows that there's no green leaf, there's, I don't know, some other icon, alert, it tells us, hey, maybe you want to turn it down. Maybe you don't have to be so warm right now. You could dial down the temperature, you could save some energy, and you could also be better for the environment. And one could say, hey, it's just me, right? What can I do for the whole environment in the world? Now think about it. Think about the fact that this device is in thousands, hundreds of thousands, perhaps even homes. So if everyone is saving a little bit, then the total net saving is a lot. So this device, it's smart locally, but it's also smart in the cloud, if you will. So not only it checks out, okay, what is your schedule, but it also checks out locally, what is the weather outside? What is the weather forecast? So it can ask that on the internet, right? What are the patterns? It can also change perhaps how it manipulates in accord with your neighboring devices, right? Maybe they have learned something already about this neighborhood and that you could take advantage of, right? So these are powerful devices that are loosely connected because, it's just in your home. It does have an internet connection, but it doesn't have to be all the time there. It's still going to be able to perform on its own, right? But it has a lot of power there. So that's what I mean when I'm talking about Internet of Things. So what I have at home, I don't have this kind of device. I have different kinds of device because in Europe, we often don't have air heated or cooled by blowing hot air or cold air through the pipes. In Europe, we have what's called, sometimes they call them batteries. You have these devices next to a window, under the window usually, that has hot water flowing through them, or perhaps electrically heated radiators. I think that's the right name, right? So this particular Nest device is not so good for that kind of environment, perhaps, because it expects the change in the air to be much faster, the change of the temperature, and that you can achieve if you are blowing hot air, right? Those radiators, they have more inertia, and also they can be, different. Some rooms may have more of them, some have smaller, some maybe don't even have a radiator, but just has the door open all the time. Some rooms may have window open, and so on. So this Nest device usually is one per house or one per floor. It was pretty expensive. It was a couple $100, I think. So I said 100 earlier, I guess, but it's a bit more. What I have is a device that you actually attach to a radiator. So each radiator has a sensor that you can set the temperature, and also on your smartphone, the temperature for that room that you would expect, and it would control the radiator individually. And also all together they would call the heating system in the house, saying that, hey, we need more heat because many radiators are on. At the same time, it will also watch whether the window is open or not. It's not using a sensor attached to the window, but it's checking the temperature drop. When you open the window, that the temperature usually drops quite suddenly. And that's when it figures out, oh, someone opened the window, so there's no point on heating right now while the window is open. So it's trying to save that way, right? So there can be different kinds of sensor devices like that. It's not just about one Nest that solves every problem. Okay. So Internet of Things. So one stereotype is that we have a thing, we attach it to the internet, and voila, we have the Internet of Things. We have a toaster, we attach it to the internet, or we have a refrigerator, we attach it to the internet, and ta-da, Internet of Things is there. It's not enough. That's my point. You have to have all these smart things attached to it. You have to have the technical solution attached to it, the programs, the software, the algorithms that will provide that, benefit. But even that is not necessarily enough. I mean, it can give you some sort of comfort, the level of comfort, but often what you really need is you need to change a business model. The way things have been done so far may not be the most efficient way anymore. So here's one example. The point here is you need to change the business model, the way things are done so far. So here's a quote from Aaron Levy in one of the tweets. So what he wrote was, Uber is a 3.5 billion lesson in building for how the world should work instead of optimizing how the world does work. So what does it mean, right? Maybe you have heard the famous quote by Ford. I'm not talking about Harrison Ford from Star Wars movie, but I'm talking about the Ford who actually created the Ford Motors, the Ford company. He said that if I'm asking people what do they want, the people would say, we want faster horses. Because people are used to horses at the time they were. So that was all there was. Just like before, we had the taxis that you would wait on the road and you would just wait for a taxi, then you would try to flag it down, and the best case scenario, you would call some number and then you would say, oh, I want a taxi, and they would tell you, okay, it's gonna be there in half an hour or so, maybe 20 minutes if you're lucky, right? So that's the old way. That's the horses. Instead of giving people faster horses, Ford built cars. And now, there's not a surprise anymore. A car, everyone knows what a car is. We know how to drive, we know how to use them. They're great for all kinds of things, right? We're not using horses that much anymore. So Uber changed the business model. The way we call taxi nowadays, we just bring out the phone and we say, I want taxi. So the phone, the application, the system figures out where you are. It may actually know what your preferences is. Do you want an expensive taxi or do you want like the economy version first? It looks up, okay, where are the closest taxis? Connects to those taxis that are close. Asks them, okay, are you ready? Can you give a ride to this person? Somebody responds from those taxis and you get the message. We'll be there in 2 minutes. So that's 2 minutes. That's not half an hour, not 20 minutes, right? It's not faster horses. That's a different way of doing things. Why can we do that? Because of the technology. This is how technology is changing the world, not just improving incrementally, but changing how things are done. So that's the thing about the Internet of Things here. Okay? So the Internet of Things is not just about making our room warmer or cooler, depending on how we feel, trying to guess how we feel, but actually, it's up to you, to people, to figure out how to change the business model, how to change the, governance, maybe how to change the system, the structure, so that you can apply this technology in a more meaningful, in a more effective way. How to make our lives more effective so that we don't have to wait for half an hour for the taxi and so on. All right. So another example is Waze. I wonder if you are using Waze application. Are you?
What is it?
Say again? What is it?
What is it? Yeah.
Okay. Let me give you an example. So I'm driving a car. I want to get to school. I have this application Waze. And I just tell it, okay, I want to get to school. So it figures out what's the fastest road. And not just it figures it out based on the map, it also figures it out based on what the current conditions of the traffic are, what the traffic accidents somewhere might be, what some other hazards might be on the road, and so on. So it's not just about giving you directions how to get there. It's also about pulling you in as the participant, as the active participant of the system. So as I'm driving, I'm also reporting automatically. I don't have to do anything. So the application is reporting what is my speed versus the speed limit. Am I in a traffic jam? So there's a big question on the side, by the way, what about the privacy of the users, right? So let's not forget about that. We're going to talk a little bit about that. But if you just, deal with that, with the privacy, then there's a lot of benefit. What people can do and what people do, they report that there's a traffic accident. And in fact, sometimes I remember there was an interview with police. Hey, do you think Waze is bad for you guys? Because people are reporting that there are, there's police on the road, trying to check the speed limit. And they said, well, actually, no, it's pretty good for us because sometimes we can get to the accident faster that way. Because the accident gets reported by the Waze users, and we don't have to wait till someone is gonna call it in, or So we have arrived at the point where I want to talk about minimum concierge value product. But before that, do you know what an MVP is? Have you heard MVP?
Not really.
Okay, so if you were to be a business student, you should have heard. Or if you had a business anyway. So MVP is a minimum valuable product, or minimum value product, if you will. Valuable. It has to be valuable to the customer, right? So when there is a startup, when a new business wants to try something out, it doesn't make sense to build a whole-blown rocket and try to sell to people, because it's going to be very expensive and the people might not like it. So it's going to be a lost cause. So better we build something small, something that has minimum functionality but still provides the value for the people, and then we'll see whether it flies or not. Are people willing to spend their money on it? Are people willing to use it? What's the feedback about this? What should we add? What should we take away? Things like that. Now, that's the MVP, minimum value product. Now enter minimum concierge value product. So this is a term, lesser known term, where concierge, it's like a human in the loop. So right now you don't have just the technology as part of your product, but you also have a human in there. And think about Uber. Right now we have a human in the loop. The driver, the taxi driver. That's a human who receives the message that someone needs a taxi. Then he responds to the message, then he drives there, and there you go, right? So is this Internet of Things solution? Well, not quite. There's a human in the loop. So maybe it's Internet of Humans, or Internet of Humans and Things, or Human Internet of Things. There are different kinds of abbreviations, as you can see on top, that you may see in the literature once in a while. All right, so we can do more. We can try out things first when we introduce a human in the loop, right? And that's also what that tweet down below is about, partially. That it's a 3.5 billion lesson because they had to invest a lot of money to get it off the ground, and they also had to learn a lot of hard lessons in the process. But they could only do it because they introduced a human in the loop. They didn't go right away, hey, we're going to have a self-driving taxi, it's going to solve everything, right? That would be too fast, too soon, and probably not working, right? So that's, I think, a good lesson to learn here, that sometimes you do need to include a human, a person in the loop. If you have a problem to solve, you don't have to solve everything using technology, but it's the key aspect to figure out what part is the technology and what part is good enough for the human to do. All right. So let's think of a couple of use cases. Let's talk about quantified person. So what's a quantified person? Let's say you can have all kinds of sensors on a person that measure the temperature, that measure the blood pressure, that measure how a person moves, whether he's just sitting on the couch and watching TV all day, or whether doing sports, whether he's limping all the time without even knowing perhaps that, right? So you can measure a lot of things about a person. You can get the information from those sensors and you can store them somewhere in a database. Is that enough to improve healthcare? Probably not. Then we are back to the story of just plain facts, right? So the average pixel of a picture, it doesn't tell us much. So we need some sort of way to analyze that data and to make a decision, or at least offer a choice of a better course of action in some ways. But ultimately, the benefit of it would be that we could provide better healthcare. We could notice the things about human health before the human actually notices these things. I mean, if you ask people, you're probably going to have heard a lot of stories where people said, oh, I found out that this is my problem, this is my health problem. Turns out I had it for a while, for a number of years perhaps even. And now finally I have found out, now finally I have taken care of it, and so on, right? So if you had this system with sensors, it could have actually given you warning earlier and brought it to the better healthcare. It could have even offered to make a better diagnosis when you are at the doctor, right? And so on. Now think about self-driving cars. So what is a self-driving car? So it's basically a car that has no driver, or at least there is a driver, but he doesn't have to participate. If there is some sort of emergency situation, then the driver can always take over. But generally the car just takes you there. When you're tired, you can save time, you can do something else during that time. Because what is the most important in our lives? The time is, of course, right? So we can save time. We can use self-driving cars for logistics. We can use it for delivery of stuff that people buy from Amazon. So Amazon has this project where they actually deliver stuff over the air. They have the flying drones and so on. There are other projects where drones deliver medicine to remote areas and so on. So it's not just about self-driving cars, self-driving anything, pretty much. So there is a lot of potential there. Smart camera. So what is a smart camera? So it's basically a camera as a sensor that is attached to the internet. It doesn't have to be attached to the internet, but it is attached to a system that can analyze the picture and that can do something. So what could a smart camera do in a warehouse? So it can automate a lot of tasks that are so far using by people that may make human errors also, as we are all human. Sometimes we forget things, sometimes we don't see things, sometimes we trip over things. The camera could watch over that, so it could help us there. The camera could also account for whatever is stored in the warehouse. If you need to locate something, and if you have, forgotten where did you put that, of course that wouldn't be a good case for the warehouse. The warehouse should have some sort of system. But let's say at home you have a smart camera and you have forgotten where you put the keys. And the keys, they may not have this smart dongle attached to them that will beep whenever you call for it or clap your hands. As I've seen, there are products like that. Or better yet, if I lose my glasses, if I place them somewhere and I can't find them. So the camera perhaps actually can follow everything that's happening as the objects are moving through the environment. And we can ask smart queries. So we can ask, where are my glasses? Where did you see them the last time? And the camera can tell you, okay, well, look at the table behind the TV or somewhere there. And oh, yeah, thank you. Great. So there is a potential. So sometimes the simple applications come to mind first, and which is fine, such as for the security applications. Okay, check who is coming in, and let's try to keep away the strangers. Or perhaps if there's someone important coming into our door, very important person, VIP, then maybe we need to prepare for that person in some way ahead of the time already, so we can figure out when it's approaching. But also for logistics, for everyday lives, for the camera, as we will see, it can even measure our heart rate. In certain conditions, certain cameras could do that, right? So there are health applications as well, right? So suppose there's a worker that works in a warehouse and he just, collapses. Something happened with him. Or he got pinned by a box to a wall or something, right? He cannot get out. He doesn't have a smartphone. What do we do? So the camera maybe can notice things like that. So there is a potential for those sensors, smart sensors there. I mean, the technology can break. and especially when you work in the software industry, you see that the software, there's this famous saying that there is no software that has no bugs. Every piece of software has bugs. And nowadays, when the software is actually driving the cars, that becomes scary. There's another aspect of the situation where if there is an accident, and there are accidents, and you have read on the news perhaps about all kinds of accidents by self-driving or almost self-driving cars because of the technology. Who's to blame, right? Do you blame the driver? Do you blame the company that built it? Do you blame the engineer that wrote the software? There are a lot of aspects like that. That's a whole another story. So for now, there are certain companies that have volunteered for, I think Volvo is one of those that say, if there's an accident because of the technology, then we will take the blame, more or less, right? They may investigate who exactly is to blame, but it's not so much, I believe, about whom should we put to prison, but rather how to actually fix that problem so that it does not repeat anymore. Now, there are problems, there will be problems, and yes, you win something, you lose something. You have a human driver, you have a technology driver. We'll see how it plays in the future. All right. Okay, so I have a couple of scenarios now, and the plan was to invite you for a discussion. Let's say we have a smart home with all kinds of sensors in the home. How can we make the Internet of Things, make sense in a smart home? How can it improve our lives, improve our economy, improve the ecology around us? And as we are getting older, we are developing all kinds of challenges, if you will. People are getting dementia. People are becoming forgetful. So forgetting the gas on, that's a real big problem in real life. It's not just a made-up problem, right? And there are systems, I have seen research being done already that actually are tackling that for people, for elderly homes. So that one thing is to turn off the gas if you forgot to do that. Another thing is sometimes people would walk out and lock themselves out. So you could have a smart lock that sort of lets you back in, or at least notifies someone that the person has left the building at the time when usually the person doesn't do it, right? All right, any other examples? You could, either you have a smart remote control and you can control whatever around in your environment, anything, light, temperature, doors, maybe something else, right? Or you could have a voice control. So nowadays we have these devices, for example, Amazon Echo or Google Home or Siri, you may have heard about as well, right? And we can give voice commands, and this voice hub, it could be connected to all kinds of sensors and devices in your home. Even in this room, right now I'm not gonna tell the light to go down or something like that, but the infrastructure is there. So a disabled person or even not disabled person, we can use the technology for remote control. Better yet, this technology, it can adapt to how we are, and if I'm moving through the rooms, perhaps it can turn on or off the lights. So I have, let me confess, all right? So we have a little problem in our home, and the problem is about forgetting to turn off the lights in the hallway. So our family is like that, but I guess it's not unique, right? So I was kind of upset about that for a number of years. So eventually I installed the lights that are actually looking at the movement. And if there's no movement, then they gradually turn themselves down. All of a sudden, we're all much happier. So it's not just about, making us more efficient. It's also about making us happier.
But Leo, may I drop the provocative question? Of course, I'm also the fan of the smart house and all these sensors, movement, lightning, twilight. It's like, yeah, my cat also has managed to switch off the lamp. But the point is, it makes our life comfortable, we rely on those technologies, we trust them. But there is another phenomenon called digital dementia. So that maybe we are relying too much, and at that one moment, we really would forget what is reality, whether the truth is there or the truth is out there. Because you might be familiar with this digital dementia phenomena that we rely that everything is in Wikipedia, everything is in Google, everything is Amazon. Ask Siri whatever you want. Even personally, I consider Siri very stupid, and etc. etc. So, but at one moment we will forget that we have brain to think.
So my take on this is that it's really up to us, right? It's up to me whether I want to climb that big mountain or not, the Kilimanjaro, or whether I want to go down the Grand Canyon in a raft, or whatever else I have done it. I could live without doing that. I could have a comfortable life in a couch in front of TV. And it's not just about dementia, not just about digital and thinking. It's about our behavior, I believe, right? And how well can we couch ourselves, coach ourselves, not couch ourselves. How well can we put ourselves in the couch is a big problem. but indeed, on the other hand, it's also a challenge for people to work on technologies, to figure out how those technologies not just can help us to remember, but also how they can train our mind, they can train our bodies. So for those example, I have a couple examples in this respect. I have had projects that attach motion sensors to kids, right? To see how kids are moving, whether they are active or not active, whether they're doing the sit-ups or something like that, right? So, and also, I know a person who is leading a project, again, with the kids, with respect to the digital addiction and physical exercise. So the approach there is first to figure out the kids have a problem. They are sitting in their smartphones. We are sitting in our smartphones. They're not moving as much as they should, as our body should, for example, right? Can we create an application, a game of sorts that actually will make them to move and love it? Not just make them, but also love to make, love to move, love to exercise, right? So you could create an application that is observing whether the kid is doing exercises, and then they can have this competitive environment with who's going to do the sit-ups, or there are many games where kids go and they have to earn some sort of currency, right? And as they are doing some mundane tasks, clicking on something, they earn more of that virtual currency so that they can buy better tools so that they can do more clicking. So that doesn't make sense, right? But maybe you can apply this kind of approach with you twist it, right? So the currency, you can earn the currency by doing exercises. Let's say you do 10 sit-ups, you get some sort of bunch of currency. And that will raise your popularity in the your local society, your local network of sorts of this game. But they'll also have health benefits, and it will not cut off your phone time completely, which would be again devastating from psychological point of view for the kid. But maybe there's a compromise. So back to your question about the digital dementia, I'd say it's up to us to see how much we rely on that. And let's remember that it's not all about sitting at the computer, but we also have to get out and go and climb that mountain sometimes, if we want to stay healthy and if we want to stay curious. Because guess what? If we're going to get everything from the internet, then the curiosity might also kind of go down. And I think that's a big driving force. So here's a challenge for you. So I'm hearing you're saying, I would also like to use something like that. How about you turn it around, and how about you provide for the community that you have around you a solution like that, so that everyone can kind of do things like that?
I would like to, but
I have lack of knowledge how to uh, put it to European society and Ukraine as well.
All right. Well, you still have time to learn something, right? And to apply what you have learned. And it's not the case that everyone knows everything how to do this. There are going to be mistakes. But if you are passionate about that, why not go on ahead and actually implement that? It's very easy to become a user, but I think it's way more beneficial to become a provider for everyone. And you can be the user at the same time and do a good thing for the society.
It often happens that people actually discourage you from taking an initiative. So, I mean, of course, there are providers, there are enthusiasts, and there are people who are bright, and like Anna. I mean, but still, I know it's character, I know it's courage, I know it's confidence, but I mean, it's easier in some places which are different than Ukraine actually.
Well, it's it's what is it, 7, almost 8 billion people on the earth. So everyone has their own opinion and is entitled to their own opinion. It doesn't mean that you have to abide by all opinions. It's easy to say, right? You will say, okay, it's easy to say that way. But what's the solution? Well, go for what you like to do. Find people that are with you and work with them, and the environment and the people, the team around you. This is what really makes us happy when we do the things we love. And I can say that from my experience. So I showed you at the beginning of the presentation that there was this medical network, and I said we created a startup and did all kinds of tests. The funny thing is that for that startup, we never met each other until the point when CNN, the company with the television network, invited us because they want to do an article on us. They want to film us, interview us, because they thought we're going to take the first place in one of the business competitions. We didn't take the first place. We took the second place in Santa Barbara some time ago. But the funny thing is that was the first time we all met together. Up to that time, we all were working remotely from different states. United States is a huge country, right? 4 hours time zone alone tells you how big it is, right? And we were collaborating, we were chatting over the internet, we were sending emails, we were calling, talking. I was doing my designs, I was making my prototypes, I was shipping them over to other people. They would write some software on them, then they would take the software to the whole solution to the hospital, someone else, and then there were some people responsible for business side of things and for the marketing and so on. It was very distributed. The moral of the story is you don't have to be at the same place physically, especially now with all the pandemics, right? You can still have fun, you can still be productive, you can still be successful. So we got the second place. I got my minute of fame being on CNN, but moreover, I got all this experience working with these great folks. And also that led to other projects eventually. That led to the point where I'm telling you about that. And that's a lot of fun for me as well.
May I ask one more question? You went to study in USA, right? So you didn't feel like you searched for opportunities in USA. So I guess in USA you thought that there were more opportunities than in Latvia, right? So that's why you decided to study there, or what was the reason? Why not in Latvia?
Why did I choose to study in US rather than in Latvia? Or why did I come back to Latvia? I like to do things with computers. And as I was chatting to people on one of the conferences that happened in Latvia, I was told about the University of Pittsburgh. There was a famous professor from the University of Pittsburgh. And after the chat, he kind of invited me to apply for the University of Pittsburgh. I applied. The first year I didn't get in for some administrative reasons, but then the next year I applied again. So be persistent. Persistence is a virtue. I got in and I got to study in a different environment, and one benefit actually was that You know, I was with people that are very devoted to the subject,
Oh,
and
yes,
also
yes.
very diverse people from all over the world. So I got to, you know, learn so many things, and not just about computer science, but also about the culture, the differences, and especially about the common things that we have coming from all over the world, and being the greatest friends together, and having, you know, the coffee at the French at the Italian coffee shop in the morning on Saturday mornings, and talking about, you know, space and planets and so on.
Oh,
So
yes.
this is the cool thing. I didn't know that it's all gonna come to me, but I did take that leap to go and study there. Now the second part is, why did I choose to come back here? It's not just about, for me personally, it's not just about making a career. It's not just about, you know, building great computers, if you will, right? I also want to have a life. I also want to have a family. And it just happened that I met my wife in US, which is also Latvian. She was just studying in a different university where I was working after the University of Pittsburgh. And we decided to make a family and to raise our kids in Europe, in Latvia. And guess what? It turns out that being in Latvia, it doesn't mean that I cannot reach the world. Since then, I've been on many occasions on pretty much all the continents except Antarctica, doing various things related to, you know, either climbing the Kilimanjaro or actually doing research or projects and so on. So go for it. That's my take. All right.
Yes, yes, yes.
So let's move on though, because the time is also not waiting, right? I had a couple more, you know, case studies for us to discuss the smart cars, but let's skip this one. Let's look at the smart city. Let's say you are in charge of city, and you have this great opportunity to introduce some sort of Internet of Things or Internet of Humans and Things in this environment. What would you do? How would you improve the city, the life of the city, the life of the people in the city? Think about it. Tell me. Okay, so we can optimize the traffic in the city. That's good.
Yeah.
That's good. And in some ways we already have those solutions, such as Waze, that allows people to submit the actual, you know, information about events, the real-time events. That's where the value really is, to get the data right as it happens, right? And to respond. Of course, then the city has to build an infrastructure and a system so that it can respond to those events. There was one project that we developed about the hole in the ground, if you will, on the road. So it's not surprised that the quality of roads, even in Latvia, is not so great, not all the time anyway, especially in winter or after the winter. The winter comes, it all becomes, you know, slushy and icy and
Same
snowy.
problem.
And after the winter, there's lots of holes in the roads. So how do you react to those holes? Do you, you know, go and look for the holes and then you patch where you find the holes? Nobody seems to be doing that, at least not very efficiently. So the system that we built was the people could report on one hand, or in fact the system was, it was a research project, so it didn't unfortunately get implemented, not at least in our city. But there was some interest from Scandinavian country when there was a startup that was gonna do something like that. Anyway, the point is, you have a system on your smartphone that is listening to the sensors of the smartphone, and as your car bumps and goes into that hole, and it doesn't have to be a big hole actually. So we were able to figure out to distinguish 5 kinds of holes that are on the roads, so that you can send that data to the cloud, and then the cloud will build a map of the holes on the city. And then whoever is in charge of the road infrastructure in the city, they can look at, you know, where the biggest problem holes is. And it's not just about the size of the holes, it's also about how often cars get into those holes. If there's a hole but not a whole lot of traffic, so maybe that's not a big deal. Or if there's a hole and the cars can kind of go around, then that's not an emergency either, right? But if there's a hole where every car has to go through it, that's a big deal. Maybe that's where we have to go first and fix that hole. So that's an example. So you can avoid the dangerous places to stay safe.
Yeah.
All right, so there could be the system like that, but it would be even better if the system would be more proactive, right, rather than reactive. But as you have this system, and I don't know what the reporting mechanism is for the why is this area dangerous? Are the people reporting that, or are there some, I don't know, cameras, smart cameras?
This police system is connected to this
Or
application.
police is reporting, basically, right? So on one hand, yes, you can avoid, but on the other hand, the city should probably think about how can you improve those dangerous areas so that they are not dangerous anymore, right? And maybe the system can help that as well. So it's not just the shield, but it's also helps to improve and correct the problems. All right, thank you. So let's move on. So there's, you can also talk about the smart world. It's a macroscope. There's no limit how far back do we go, how much information do we try to get in. And if we look at the logistics of the smart world, we could have sensors, and this is happening already, that's looking at the weather all over the globe and try to do predictions. And then we can have, the help of the artificial intelligence systems that we feed the data and they make predictions better in some ways sometimes than even the older systems. But that's not the only way to approach this. We can also talk about logistics. We can talk about how to optimize the shipping routes where you have to ship goods or supplies across the oceans from place to place. Or we can talk about monitoring the quality of high value goods. For example, if you're shipping certain microchips, if you will, or electronics devices, then they have to be under certain conditions. Otherwise, they're just going to spoil. We don't have to talk about microchips. We can talk about food. We can talk about medication that also has to comply with certain standards. And those may not always be, kept. There could be, temperature differences too high, and that will make, for example, a vaccine, if it's not in a cold enough environment, then it may not be usable anymore, right? How do you make sure that it was at that temperature all the time? So maybe you have a sensor or a network of sensors that are following the shipping of this vaccine and monitoring the environment and telling you at the end, so everything is fine, or no, unfortunately there was an incident at this location at this time and this is not valid anymore, right? So there could be more stories about what to do in the world. I'd love to chat about it, but I think we have to move on. So here are some of the examples of certain. So we talked about the big picture. We talked about the big companies in the world and in the city and or in the house. But what about what about the focus, keeping the focus, the smaller companies, or at least that are targeting the smaller, subjects, if you will. So there are companies, for example, that are providing the remote monitoring by doctors, or you could have a remote visit to a doctor. And this was even before pandemics hit the world. So it's more than a couple of years old, this picture, let me be honest, okay? So then there are companies that are, the kind of sensors that we're using could be used for very unusual applications. For example, you could have a bracelet that is monitoring how your wrists are moving when you're washing your hands, right? And you may think, okay, so what's the big deal? The bracelet is watching my hands and, right? Where's the big money coming there? What is it going to say? It's going to tell me no, and that's going to be it? Well, think about it. Here's the data that comes from the United States of America, from their hospitals. So it turns out in a year they get about 1.7 million infections. And most likely a big part of those infections are because the hands were not properly washed. I mean, there might be some other reasons, right? But part of it comes from that. Is that a big deal? Let's see. So each infection costs about $15,000 to treat. Healthcare is quite expensive in US. So as a side note, if you are in the US, you have to have health insurance. Otherwise, you will go bankrupt really fast if something bad happens, right? So each infection costs about 15,000 to treat. So multiply those two, you get about 13 billion that you could save. Not even talking about the health of the people that got that infection, right? A similarly silly thing, a bracelet that watches the movements of the wrist. If it's done well, if it can monitor and tell really whether the motions are correct, it can save lives, it can save health, it can save a lot of money too, right? So just an example of what we could do, or what is being done already. So there are a couple of companies that are doing that. Swipe Sense is one of those, I believe. Hygienix is another one. Now, Internet of Human and Things. So how can things and humans collaborate? So here's another example. So there's a company, Takti, I believe, that was working at some point on smart power tools. So imagine you have a power tool that is cutting in the board and doing something on the board. And as you move it across the board, so this power tool knows when to cut and when not to cut, right? So on one hand, you have specialized, very big devices, work tables, so-called CNC stations that have motorized stages that move the cutter and precisely cuts where it needs to be cutting and all that. Yes, that solution is out there. That solution costs a lot, and that solution takes up a lot of space. Now imagine you have a smart power tool. It's small and compact. You can take it to your garage. You want to make something, you download the image. Let's say you want to cut a picture on the board, right? Make a picture, more or less. You could just download the image, and then you just move kind of that device across the table, and it figures out where it is on the table, and it cuts depending on when the opportunity is for it to cut at the right place. So it's a kind of interesting, strange collaboration between a human who doesn't know much about what to do exactly, maybe roughly knows where the picture should go, and the machine that actually assists with all the digital smartness that it can. Just another example. So society and data. When we're making systems, the sensor systems that is observing certain things, turns out that it is much more valuable to observe the action rather than just opinion. So people may have different opinions, and they may voice different opinions, be it on Twitter or by voice or in some social network, other social network. But if you see what they're actually doing, that's much more worth it. And based on that data, you can make again decisions about whatever the problem is at hand. So one example, there's a researcher, Professor Sandy Pentland from MIT. So he has quite a few projects, in fact, that is observing how humans behave using sensors. Sometimes you have a smart badge, and the smart badge looks at, okay, where do you walk around, who do you meet, who do you talk to, how long, and so on, right? Or he also had another project that looks at smartphones. Smartphone has an application, and as the people are moving through the city, where the people are, which restaurant do they go to, and so on. Again, let's keep in mind the privacy needs to be preserved. But if you can take care of that, then there are a lot of interesting things you can tell. So from his research, Sandy Pentland, once again, is the name. For example, he has figured out that if you look at what people do, action, remember, rather than opinion. People may say, oh, there's this great restaurant, right? But when they really go to that restaurant, that tells more about them or where they go in the city. And turns out, if you look at the group of people, which places do they go, eventually you can predict which people gonna meet which people eventually and become friends, if you will. So crazy, sounds crazy, but that's what his project, sort of one of the takeaways from his project. he has a lot of amazing projects. He has a project, for example, where there are different competitions by DARPA, Defense Agency at US, and one of them was that, at some point of time in the whole United States, there will be, let's say, 10 air balloons, like the weather balloons, released with a certain kind of mark so that you can know. The team that will tell first where all the balloons are will get the first place. And the first place is something like $1 million, $2 million. A lot of money, basically, right? So his team figured it out, and with their approach, they got it in 4 hours. Anywhere in the US, in 4 hours, they were able to give you the whole map. And they leveraged not just technology, and not so much technology, but rather the behavior of people and the actions of people. So there's a lot of power in there. That's the takeaway here, I think, right? Now, as we're looking at society, as we're looking at a lot of data, how people, act, react, behave, that's a lot of data. We need to look at statistically significant part of that data, and there's a science behind there. It's good if you have a good friend who is a good statistician as well. And then you can see which conclusions make sense or which conclusions may be coincidental. And even then, you have to kind of watch out, because sometimes you can get false correlations. I think there was one correlation that the birth rate was kind of having the same pattern across the time as the popularity of one funny movie. It's purely coincidental, I would want to say, right? But hey, things like that, funny things like that may happen with the data. You have to be really good at reading the data and doing analysis, right? And it really helps you also have human in the loop, once again, that looks at the data, that uses experience or intuition, if you will, to figure out what's the deal with the data. And let's never forget the privacy, because whatever we do, we need to respect the privacy of the people that have decided to give the data to us, right? So a number of years ago already, Amazon created this shop. It's called Amazon Go, meaning you just go in, you take what you want, and then you leave. What's the benefit? You don't have to wait in lines. You don't have to, you just go in, take what you want, and leave. Of course, you will get charged, but you don't have to wait in lines at the cash register. You don't have to spend more time that you need in the shop. Sounds very convenient. So how can you do that? If you ask Amazon, then of course everything is closed. We're not going to tell you. It's our business secret. Now, if you're looking at patents, though, then you can see that there are a lot of sensors on the shelves, all kinds of sensors, also cameras looking at things, computing resources, and so on. So there is a system in place that will track the items as people are taking those items and putting in their carts and then exiting the store, and then of course charging those customers the appropriate amounts of money. So the challenges for the IoT. So nothing is for free. All those good things that we talked about, they cost something. If you are, either a policymaker, or if you are a business person who owns the business, who's in charge of business, you have to consider the following: that as you are considering implementing IoT solution in your business, whether it's a smart camera in a warehouse or anything else, you're going to have a lot of data to deal with, right? Once you have this data coming in, obviously you're going to need to store it somewhere. So this means maybe you have to have a big server somewhere in your company, or you have to rent a server somewhere online or in the cloud, right? And you also need someone to manage this data, right? And once you have the data, it's not enough. It's just numbers. You need to invest in the analytics. So there could be quite a bit of complexity in the data that come both with the size of the data, and also with the structure of the data, and everything that comes with the data, right? So again, that's one thing to consider, that you need to either hire a professional team or maybe outsource it to someone else, for someone to actually make sense of that data, so that you could get actionable, things to do from that data, reaction. Otherwise, there's no point investing in IoT, right? And also you need to probably invest in automation, because once you have those first two things set up, you have data coming in, you have a team or a software that's doing analytics on the data and giving you the suggestions. What should you do? Should you turn on this or that? You actually have to turn on these things somehow. You have to provide the automation for your processes. Perhaps things that have not been there before. Perhaps the lights were always connected just to the wall switch, but now you have to enable some sort of remote lights on and off type of switch, right? So this comes, there are technical challenges, but there are also, you have to figure out what are the benefits and also what are the risks. Because as said earlier today, sometimes technology does the wrong thing, or sometimes technologies break, right? So what if all of a sudden everyone's going to turn on the lights in the whole factory? So seems like, okay, who could it hurt? But at the same time, maybe that's a big addition to your bill that you're going to have to pay, right? So these are the main challenges from sort of a business perspective that you have to think about when investing in IoT. So is it worth really doing that? And now comes the part where I was going to invite you to think about 4 scenarios for the healthcare, for home, like a smart home, for a hotel business, or for the whole city. What is the IoT potential in business? And there could be these 3 areas to think about. Can we optimize expenses somehow? Can we make, can you save money? Can you make things cheaper maybe? Can we lower the risks? Every business, every action comes with a risk of sorts, right? Can it help growth? Can you grow your business in some way? Okay, so if we're thinking about the healthcare, for example, optimizing expenses. Let's say I have a clinic of sorts, an ambulance maybe. People are gonna have fewer visits because they can do remote. For example, they can sign up for the visits remotely. They don't have to call as often. They can do many things online. We could even perhaps have a remote visits, if you will. They don't have to come in. They don't expose my medical staff, my clinicians, to infections, for example, and so on. Okay. How about home? So if we're optimizing, if we're putting, the smart thermostat in the home, we're gonna lower energy consumption, just as in the beginning of today's story. Hotel. So we could do better key management. So just imagine that, long time ago, you go to a room, you had this physical key that you locked the room in the hotel. I mean, at home, most people still have this physical key, and, we love it. It's something we can see, it's something we can lose, and so on. But nevertheless, that's what we do. In the hotel, quite often nowadays, you can see those key cards. And, for many years already, we have key cards that are magnetic, but now we have the so-called chip cards as well, which have the benefit that for the magnetic card, if you put it next to the magnet, then you ruin the information and you can't use it anymore. And also you can sort of read it in a different device and sort of copy that way. But now you have the better key management. As the customer comes in, you can give the key right away to the person. You don't have to search for it in the cabinet behind you or somewhere, right? And you can give as many keys as the customer really needs. You just program each key for his room, and he will get in. He will get in that room only when it's his time, for the time he has paid for the room, right? And he will not be able to copy the room. So I'm kind of already in the lowering risks section for the hotel. No lost keys, better room security, right? Now the city, you can have effective service, right? If you have some sort of network that oversees where are the holes on the roads, where is the city clean or not, where the lights, the street lights maybe are working or not working, then you can much more effectively, much faster respond to the alarms and fix the problems, right? If you do it later, then it may cost more, or it may create accidents that will add to the cost, that will add to the overhead of other city services that need to be involved, right? So optimizing expenses, check. So that's good. Lowering risks. In the healthcare, if we are using sensors, let's say, on a person, we can provide better diagnosis. So we can give a person the sensor, let him live for a day or two in his natural environment, and then we can check the data to see, for example, what is his heart rate, how is it changing, are there oversteps or arrhythmia in his heart rate, or what about his movement, is he limping, for example, maybe, and doesn't even know, things like that. And also we can check the compliance. But for example, if we give a person a smart pill box, we can see whether the person is actually taking the medication or not, as he is supposed to. But because quite often people, when they come to the doctor is asking, okay, did you do everything I told you? And they say, yes, I did, right? I mean, it's so embarrassing. I'm not going to tell that I forgot to take my medication yesterday, right? This way we can provide better and more precise diagnosis and therefore lower the risks. For the home case, we can do remote management, alarms. So I have again one experience when I went on a trip from my home, and the pipes broke down. Basically, I had a lot of water in my home when I came back. So it was not pretty, it was not nice, I was not happy, and it was also expensive to fix everything in the home, right? Now, if I have a smart monitoring system in the home, it can alert me right away if there's a problem, if the pipes broke, then I can call a service or neighbors at least, and they can come and check it out and take care of the things and minimize the risks that way, right? We did talk about a hotel, no lost keys and better room security. So for the city, if you have this information system in place that is following the sensor data, for example, it can make more informed population, which often may mean more happy population as well. Not always, mind you, right? Especially if the news are bad, but at least if it's informed population, then it can act accordingly. If there's a traffic jam, the people don't have to drive there. They can drive around. So there are lower risks to add to that traffic jam, to actually create accidents in that traffic jam and so on. And also collaboration lowers risks. So here, what comes to my mind again is this Waze system that we talked about, or you have your own system, where people can actually report the problems way in advance before they become known to the city services through other channels. And finally, the growth. Okay, so how can we grow the business? How can we, provide better service, provide more service to our customers, and grow, become, bigger and more useful service to the people, to the world. So a lot of it has to do with user experience, how to improve user experience. So for the health case, if you give more tools to the doctors, so the doctors can have, on one hand, they can do a more precise diagnosis, but they can also handle more cases, perhaps. If you, for example, create the system so that the information that comes to a doctor is very concise, very straight to the point, the doctor doesn't have to spend their time or her time to look around for, okay, where do I look up this, where is that? It gets everything at the fingertips. So it can deal with the job. It has more time for the next job, or maybe for learning something new, right? For improving their experience. In the home case, clients control their environment. So by the way, remote interaction, you can also reach further. You're not limited to only the customers that live next to you, but you can also reach people, you know, even from other countries, if you will. Home. Clients control their environment. So if we are in control of our environment, well, then we can, it may open new opportunities for us, right? And also it may make us happier in our habitat, right? Just as I mentioned earlier about the lights that turn on or off if nobody is using them, right? So I don't have to worry about, you know, spending more on the electricity bill. I don't have to be upset at other people in my family for forgetting to turn off the lights, or they don't have to be upset at me because it just takes care of itself. And in case of the city, we have real-time news. We can have better planning for the city, having the real digital data about what's going on here, and we can grow our city in a good way, right? We can make it a better environment for everyone, right? So these are just a few examples. There's way more that could be done, of course, but these are just a couple of case studies for us to think about it. So finally, the last thing I'd like to give you is the summary of what I've talked about today. So Internet of Things is not just about things. It's about changing the world, changing the way we do things. Not just about the things that we touch. So think about the Uber example or other examples. Think about how we could do medical visits, how we could do, you know, already now we're doing remote work a lot in the world, right? Thanks to technology. Thanks to this technology, I'm giving you a lecture without even being in Ukraine right now. Okay. Now the other takeaway I'd like us to have is that if we just look at the averages or some indices about the data, just look at the values. It's gonna tell us, okay, so look at that. Look at this soccer player. He's running at this speed, at 15 or 20 almost kilometers an hour. That's amazing. So what? Okay. Is it gonna make a better score for the team as a whole? Is it going to improve the experience for the viewers in some way if they know the speed? Not necessarily. So we need to analyze the data to actually get the meaningful information about it, to get the deep understanding. And that's a lot of art and a lot of science behind there. There's a lot to learn about that. Let's just keep in mind that it's worth doing it. Just numbers is not enough. And finally, data is very useful when it's shared. Just keeping to myself data, of course, I get the most of it. I get the privacy. I'm so happy. But if I share my data about my driving, for example, then others can see whether I'm in a traffic jam or not. They don't care that I'm in the traffic jam. They care that there is a traffic jam and they can avoid it. If someone else isn't in a traffic jam, then I can avoid it, thanks to the fact that we share this data. We do need to keep in mind privacy, which I should have written here again, like the third place on my slides. But we also need to share the data if we want to see the big picture and at real time. So there can be, you know, consequences for public health, for example, and also for effective urban environment using the Waze or well, Uber is not so much about data sharing maybe, but in a sense it is. I mean, the taxi drivers, they share where they are, and therefore the system can make a decision. Okay, so here's the closest taxi for the customer. The taxi gets business, the customer gets service right away. Everyone is hopefully happy, right? So with all this knowledge, guess what? Now it's your turn to take it in practice. That's all I wanted to tell you today. If there are some questions, I'm ready to answer. Otherwise, thank you very much, and I'll bid you good night.